Hello everyone, today we're going to be taking a look at Quantipus number 9, which is another relatively simple brain teaser problem. In this situation, we have a rabbit who sits at the bottom of a staircase with n stairs. The rabbit can hop up only 1 or 2 stairs at a time, so how many different ways are there for the rabbit to ascend to the top of the stairs? And by ascend to the top of the stairs, basically what they're saying is that, this is not a rabbit, but I can't draw a rabbit, so one way of getting to the top of this staircase would be going up 1 stair at a time, and then another way would be going up 2 stairs, and then going up 2 stairs again. A third way might be going up 2 stairs and then 1 stair and then 1 stair. So you see what the problem's asking here. So we need to generalize to a staircase with n stairs. So like all brain teasers, we're going to start with the base case. Let's just say we have 1 stair. How many ways are there for me to get to the top of this stair? Well, I can only obviously go up 1 stair. So that's just going to be one way, right? So now we can define this function. Let's just define a function for convenience called f, which takes in the number of stairs and outputs the number of ways to get to the top. And now we can look at the 2 staircase. If I'm at the bottom of a staircase with 2 stairs, how many ways are there for me to get to the top? Well, notice from this position, there's one way for me to get here. And where am I here? I'm back in this case. So this is where the recursion's happening. Once I go up 1 stair, I'm back in the situation where there's 1 stair in front of me. So f of 2, now that I have 2 stairs, is equal to 1 times the number of ways of getting up 1 stair, which is f of 1, plus now I can just go up 2 stairs. So that's another way. So I'm adding on one more way. So now f of 2 is going to be equal to f of 1, which is 1, plus 1, which is now equal to 2. Now let's look at 3 stairs. So I'm at the bottom of a 3-stair staircase. I have one way of getting to the situation where now there's 2 stairs in front of me, f2, right? So f of 3 is f of 2. And then I have another way of getting to the situation where there's 1 stair in front of me, f of 1. So f of 2 plus f of 1. F of 2 is 2 and f of 1 is 1. So now this is going to be 3. Let's do one more. If I have 4 stairs in front of me, I have one way of getting to the situation where there's 3 stairs in front of me, right? So f of 4 is equal to f of 3. And then I have another way of getting to the f of 2 situation because now there's 2 stairs in front of me. So plus f of 2. And now you can see the pattern, right? F of 3 plus f of 2 is going to be equal to 5, right? And you can now see, we can now pretty clearly generalize to the n stair situation. Basically, if I'm at the bottom of n stairs, then I can get up by going once to f of n minus 1 or to f of n minus 2. And this is the final answer. This is actually a Fibonacci sequence, and this is also, if any of you have done LeetCode, this is a dynamic programming problem as well. So pretty simple recursive brain teaser here.